Howdy, this is Geometry Notes 6-1, Angles of Polygons with Mrs. Moslick. Pause the video, do the warm-ups, and then play the video when you're done. All right, so compare the given measures. We have measure of angle ABD. ABD is this one, let's just call it X. And BDC, from B to D to C, let's call it Y. Since this 5.5 is bigger than 5.1, bigger angle opposite the bigger side, smaller side opposite the smaller angle. So we know that X is bigger than Y. Who got that? Excellent. Number two, remember what you can do is you can add the two side lengths and subtract the two side lengths to get the range of values the next uh, for the third side. So the third side of this triangle is between 5 and 19. So which is the least possible whole number? It cannot include 5, so the least possible whole number is 6. Okay, that's review of chapter 5. Let's go ahead and talk about polygons. So what is a polygon? A polygon is a closed figure formed by segments. So first of all, it's a closed figure. So you can't have, oh, so I'm sorry. So you can't have it in that it's open. And they're segments. So you can't have something like a circle or anything that's curved side that are connected by their endpoints. So you can't have like here because this is not connected by an endpoint and they don't overlap or cross. So those would be all non-polygons. So concave polygon, it means we have to have all segments. It's a closed figure connected by their endpoints. Segments don't overlap or cross. Concave means it looks punched in or caved in. So all of these would be examples of like concave polygons. Anything that has a punched in look to it. Okay, now a convex is anything that does not look punched in. And so these are all pictures of convex polygons. Okay, so that's what we're going to be looking at in this chapter, convex polygons. And convex polygons are made of triangles. So you start at one vertex and draw all the diagonals you can for that polygon. We don't have any diagonals here. Here we have one. Here we have two from a side. And here we have one, two, three. So meaning how many triangles are in each of these? There's one triangle. There are two triangles formed, three triangles, one, two, three, four triangles. So if you have a three-sided object, that's called a triangle. The number of triangles is 1, and we know by TAS, triangle angle sum theorem, that the sum of the measures of a triangle is 180 degrees. If you have a four-sided object, that's called a quadrilateral, and the number of triangles is 2, so the sum of the interior angle measures would be, we have 180 plus 180, which is 360. So 360. Or you could kind of think of it as we have two of those 180s. A five-sided polygon is called a pentagon. And there are three triangles. So we have 180 times 3. So that's what, 540 degrees. And then we have six sides. It's called a hexagon. Hexagon has four triangles. And so that would be 4 times 180. So 4 times 180 is 720 degrees. So like let's say we had an N. So that's called an N-gon. And there would be, well, let's see. If there were three sides, we had one triangle. Four sides, two triangles. Five sides, three triangles. Six sides, four triangles. So if we have n sides, how many triangles do we have? That's correct, n minus 2. So our answer for the sum would be, note how we're doing this. It's 1 times 180, 2 times 180, 3 times 180, 4 times 180. So this would be n minus 2 times 180. Or a more typical way to write this down would be the sum of the interior angles equals 180 times the quantity n minus 2. So that is a formula you need to know. Be familiar with it. If you forget, just think about this chart of how we got that. Now, for this chapter, I need you to know the names of other polygons up to a 12-sided polygon. So let's do some review here. So hexagon is 6. If we have 7 sides, that's a heptagon. You can also call it a septagon, but most people will call it a heptagon. 8 is octagon. 9, nonagon. 10, decagon. 11 is 1 plus a decagon, so it's an undecagon. And 12 is 2 plus a decagon, so dodecagon. Decagon. If it's anything more than 12 in this class, just write down that number and then gon. So 13 gon, 14 gon. If it's any random side like n, you just call it an n-gon. Okay, so let's go ahead and use this formula. The sum of the interior angles is 180 times the quantity n minus 2. If you have a regular polygon, all sides lengths are the same. All interior angle measures are the same. So one interior angle measure for a regular polygon would be 180 times the quantity n minus 2. That's listed on the back side. So again, the sum of the interior angles is 180 times the quantity n minus 2. If we have a regular polygon, meaning polygon, all side lengths are the same measure, all interior angles are the same measure, then one interior angle is that sum divided by the number of sides or the number of angles. Number 1, find the sum of the interior angles for a decagon. First of all, identify how many sides that is. That is at 10. So we'll use the formula. Please write it down. Sum of the interior angles equals 180 times the quantity n minus 2. So we have 180 times 10 minus 2, which is 180 times 8. 180 times 8 is 1,440, and that would be degrees. Number 2, find the measure of each interior angle. So when you are given one interior angle or each interior angle or an interior angle, that is all this formula of a regular polygon. So is like one interior angle is equal to 180 times the quantity n minus 2 over n. Octagon is 8, so we have 180 times the quantity 8 minus 2 over 8. So that's 180 times 6 over 8. So 180 times 6 divided by 8 is 135 degrees. So as long as you know the formulas, write them down, use them. Okay, number 3, find the measure of each angle. Now, we know from the chart from before that the sum of the interior angles of a quadrilateral is 360. Let's say you forgot that, or you have a problem where it's like a heptagon and you just don't know what the sum of the interior angle measures is. So let's go ahead and use that formula first. Sum of the interior angles is 180 times the quantity n minus 2. Now in this case, n is 4. There are 4 sides. So 180 times 4 minus 2 is 180 times 2. Now if you already know this number, there's no need to write all of this, but if you don't, that would be required. And now I know that the sum is 360. So my next equation is I'm going to take each of these, add them. So 5x plus 11x plus 4 plus 5x plus 11x plus 4 equals that sum of 360. Add like terms. So we have 5 plus 11 plus 5 plus 11, or in other words, 16 plus 16 is 32x. And then we have 4 plus 4, so plus 8 equals 360. Subtract 8 from both sides and divide both sides by 32. Make sure you're answering the question. So I get x is 11. What's the question? It says find the measure of each angle. So I'll replace x with with 11. So 5 times 11 is 55. So this angle is 55, this angle is 55. And then 11 times 11 plus 4 is 121, plus 4 is 125. And now one thing I want to give you a preview is later on in this chapter, we're going to be talking about properties of parallelograms. Now, a property of a parallelogram is we have two pairs of opposite congruent angles, and that's what we see right here. Okay, so we're done with this problem, and now we're going to move on to a more tougher problem, which is we are going to be using some algebra. In this next problem, we're given the sum of the interior angles, and we want to find how many sides there are of that polygon. So what is n? And so we are going to use the formula for the sum of the interior angle formula and actually the one interior angle formula, because we are given that one interior angle of a regular polygon, and then we have to solve for n using algebra. So try it as my Microsoft Word is thinking right now, and I will catch up to you. So hopefully you wrote down the formula for one interior angle is 180 times the quantity n minus 2 over n. Now they give you that it is 150, so 150 equals this formula. We need to solve for n. This is an easy algebra problem if you did well in algebra, but there's always hope, remember. Okay, so the easy way to do this is to write this as a proportion, cross multiply, or in other words, just undo the division and multiply both sides by n. So I'll show you just cross multiplying, but again, it's the same concept as I'm undoing this division. I'm going to multiply both sides by n. So cross multiplying, or in other words, multiplying both sides by n. So we have 150n equals 180 times the quantity n minus 2. So again, we're trying to solve for n in this problem. It's a delightful problem. I'm going to start. Not only do you have to know your geometry formula, you also have to know how to solve using algebra. It's a great problem. You will definitely see a problem like this on an assessment. And so we have negative 30n equals negative 360. Divide both sides by negative 30. Now, on a problem like this, you know you have to have a positive integer answer because n is the number of sides, so it has to be a positive integer. So n is 12, or in other words, it's a dodecagon. Last problem is a polygon exterior angle sum. The sum of the exterior angle measures of a convex polygon is 360. These are your exterior angles. They will always add to 360. It doesn't matter how many sides of your polygon you have. So we have the sum of the exterior angles. Exterior angles is 360, and that is 139 plus 6x plus 9x plus 2x. That sum is 360. And now just solve for x. So we have 6 plus 9 plus 2 is 17. Subtract 139 from both sides. So 360 minus 139 is 221 divided by 17. X is 13. They just want us to find x. Number 6, find the measure of each exterior angle. So one exterior angle of a regular polygon is that sum of a regular polygon divided by n. And so we have dodecagon, that's 12. So we have 360 divided by 12. 360 divided by 12 is 30 degrees. We are done with this. Let me just summarize what you have to know from this lesson. You have to know that one interior angle of a polygon is 180 degrees times the quantity n minus 2 divided by n. If it is a um, a regular polygon. The sum of the interior angles, so sum of the interior angles is 180 times the quantity n minus 2. The sum of the exterior angles is 360 degrees, and one exterior angle is 360 divided by n. So to look at it this way, you really only have to know two formulas. You really only need to know the sum of an interior angle, of all the interior angles of a polygon, and the sum of the exterior angles. Once you know that, then you just divide that by n to find one interior angle, or of the interior angles, or one exterior angle. So four formulas to know, but you really only have to really understand two of them, as long as you understand when you're taking one angle of a regular polygon, just take that sum divided by n. Hope you guys are successful in this practice. If you have any questions, let me know, but please write down these formulas, one formula for each problem that you're working on. Have a great time. And again, if you have any questions, go back to these notes or ask